Okay, we're going to start doing calculations with moles, and the first thing you're going to have to be able to do is use scientific notation in your calculator. So I'm going to show you a couple of different calculators here, and you've got to follow these rules very carefully. So if I want to put in the number for a mole, which is 6.02 times 10 to the 23, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. What that means is there's 23 placeholders after the 6. So one's a 0, that's your first one, the second one's a 2, and then it's zeros. This number is astronomical and wouldn't be used for anything other than counting atoms. To put this in your calculator, put 6.02 in your calculator. You are going to be tempted to hit the times button. Don't. That's what EXP does. So if you have EXP or if you have a button that says EE, put that in, then 23. I'm going to do that one more time. So it's I'm going to do that one more time. 6.02 EXP 23. That's the order you put it in. Now, in this calculator here, just a different calculator, hopefully doing the same, a similar thing, if I have it working. Okay, so I'm going to clear this. I'm going to go 6.02. With this calculator, you've got to hit the second function button, because it's up above the x minus 1. I don't know if you can see this, but it says EE right there. So I'm going to hit that, and then I'm going to hit 23. And that's how you get 6.02 exponent 23 on there. Okay, here we go. We're going to do some calculations. So the great thing about this is it gives us a lot of versatility. We can take a mass that's given to us and convert it into a moles. We can convert a moles into the number of particles, and then we can go backwards from particles to moles or moles to mass. Here are your formulas. N is moles. Moles equals mass over molar mass. Remember, molar mass we always get off the periodic table, so we look the molar mass up. In a lab, mass we would weigh in grams on a mass balance. Particles equals moles times 6.02 times 10 to the 23. Moles equals particles divided by 6.02 times 10 to the 23, and mass equals moles times molar mass. In a lab, these are your useful ones right here. Those two calculations are the most useful ones. It takes a little bit of work to get used to these because they're not intuitive, but if you have these calculations in front of you, you will get through it or pick it up quickly. What is the mass of 2 moles of H2O? So what I do is I go up here and I look for my formula that has mass in it. There's mass equals moles times molar mass. If I have 2 moles of H2O, it's 2. How do I find the molar mass? I go to my periodic table, I look up hydrogen, there's 2 of them, 1 each, and oxygen 16, that's 18. Mass is in grams, that's 36 grams. Next question. If you have 3 moles of H2O, how many particles or molecules is this? So the first thing we need to know is, what is a particle? A particle is anything we want to count. It could be golf balls, it could be atoms, it could be molecules. To be honest, it would never be golf balls because they're way too big. So it makes no sense to count golf balls using moles. So we're usually talking about atoms like gold atoms or molecules like water. So particles equals moles times 6.02 times 10 to the 23. So it's 3 times 6.02 times 10 to the 23. If you put this in your calculator, you will come up with 1.8 times 10 to the 24. You should try that to make sure that everything is working for you. 3 and 4 get ever so slightly trickier, but not much trickier. If you have 36 grams of water, how many moles do you have? So here's why this is ever so slightly trickier. It's because you have two formulas that allow you to solve for moles. We are going to use this formula because they give you a mass in grams in the question. So I'm going to go to number 3. I'm going to go moles equals mass over molar mass equals 36 grams of water. If I look up the molar mass of water, you go to the periodic table, 1 for hydrogen, 1 for your second hydrogen, plus 16 for your oxygen. We're at 18. We have 2 moles of water. You have 1.2 times 10 to the 24 molecules of H2O. How many moles is this? Once again, if you go back to that flow chart, there's only one formula that has particles or molecules in it. And it looks like this. So all we're going to do is we're going to insert 1.2 times 10 to the 24 divided by 6.02 times 10 to the 23. Do this with your calculator to make sure that you can use that calculator. The answer there should be 2 moles. If you've done it right, you should get 2. Okay, here's the highest level question. It says, how many particles or molecules is 18 grams of water? Well, looks easy. Particles equals moles times 6.02 times 10 to the 23. So far, so good. Here's our issue. They give us grams. There's nowhere to put grams in here. If you ever get a question that you cannot solve using a formula, go back to the formula below that or before that one. So you go to moles equals mass over molar mass because you can't just use this one. So if you get a formula here and something's missing, you have to go back one formula. Whenever you need to solve a problem you can't solve because you can't put the right thing in the equation, go back one formula. So I go back one formula. I do have a mass. I do know it's water. 18 divided by 18 is 1 mole. Whoops, sorry folks. I'm going to say that again. What I've done here is I've gone back one formula on that flow chart. The formula before it, moles equals mass over molar mass. 18 over 18 is 1. Now I can insert the moles in here. So there are 6.02 times 10 to the 23 particles of water if you have 18 grams of water.